This is MAC 1140, final exam, question 16. And it asks, it gives us this rational function, and it asks us where does it have a hole. Okay. A hole is where the function is undefined, but it doesn't change the way the graph looks at all. What this means is that algebraically, your algebraic function will be equivalent to some other function, but minus that hole. So, as a quick example, think of how about x squared, but we'll multiply on the top and bottom by x minus 1. So, I mean, it's still a graph of x squared, right? But now we have x minus 1 on the bottom. We can multiply this out. What does it mean? It's going to be x cubed minus x squared over x minus 1. So, like, the way these problems work is they give you this, and they say, okay, well, they give you, like, the final thing, and they're asking us about a hole. Well, keeping this in mind, this is the way that it looked before. We had x minus 1 over x minus 1. We would, like, cancel out these x minus 1s, and we just have x squared. So, right. But what's different is, well, here's a parabola. Here's x squared. But our function of interest had x minus 1 on the bottom. What that means is that this function is undefined at x minus 1. I'm sorry, at x equals 1. Because at x equals 1, the bottom is 0. So that means that there's a hole at x equals 1. So that's like how you think of a hole algebraically. But what it means here is that you want to factor the top and the bottom of a rational function completely and see what cancels. Because what did we see here? The x minus 1 canceled, and the x, wherever that factor was equal to 0, that was where we had a hole. So wherever your factors cancel, if it cancels completely, then if your factor cancels completely, then you'll have a hole there. So let's see if we can get any factor here to cancel completely. So factor our top and our bottom. All right, they're both quadratic, so they'll both factor like this, hopefully, and they'll both. Each leading coefficient is 1, so these will both start out with x here. All right. So we'll look at the top first. X squared minus 5x plus 4. We need to look at numbers, factors of 4 who add up to negative 5. Well, since we're adding up to negative 5, there are going to be two negative numbers that are adding. Okay, well, what two negative numbers add up to negative 5 who multiply to give us positive 4? Well, negative 1 and negative 4. Those are our numbers. And x squared minus x squared plus x minus 2. What are factors of negative 2 that add up to give us positive 1? So we'll, okay, well, what are the factors of negative 2? So it'll be either 1 or 2, right? And how do we get 1 or 2 to add up to give us negative 1 with negatives thrown in appropriately? Well, I think it's negative 1 plus 2. Those multiply to give us negative 2, and they add up to 1, the coefficient of the x. So now this is the factored form here, and we see that we can cross out the x minus 1. All right, so this ends up simplifying to x minus 4 over x plus 2. And now the reason we can say this is a hole is because of it was there before, and now it's not there. Pretty much simple as that. Like, before we had an x minus 1, which meant that the function's undefined there, and now it cancels out with the top. So pretty much the graph of this looks exactly like this, but a hole at x equals 1. In fact, you should denote here that x cannot equal 1. But anyways, that means that there's a hole at x equals 1. And So the question is asking for a hole at which point? Well, this is the x value. To find the y value, just if you plugged it back into your original, well, you can get here. You get 0 over 0 because, like, look at your factored form. This factor would be 0, and this would be 0 as well. So what you need to do is take your x that you canceled out and plug it into your simplified version. So that means that f of 1, we'll plug 1 into here. So x equals 1, y equals this, so 1 minus 4 over 1 plus 2. Work that out. 1 minus 4 is negative 3. 1 plus 2 is 3. So y is equal to negative 1. So our hole is at the point 1, negative 1. And that is answer choice C.